Hi guys, my name is Hasan Said Soylu, and I will present you in this lesson XOR gate, and we will make the electronical version of the XOR gate. This lesson will be more complicated. Wish you will understand. Let's start to delete these components. Let's pick our XOR gate. As you can see, we have it. It's too complicated. As you see in the PCB preview, it has what, three, 14 legs. So it has own uh, microcontroller in real life. As you can see, we have the XNOR gate, and let's pick our logic inputs and outputs. Where was it? Yes, here. Let's pick our output and the input, and let's put here and here and here. As you see, let's start and understand how does it work and write in front of the circuit. Yes, as you can see, if the inputs are 0, two of them 0, the output will be 1, and whenever one of them is 1, it will be 0, and whenever the other one is 1, it will be 0. Whenever we make the outputs, all of the inputs 1, it will be 1. So let's write it here. Let's first stop the engine. Let's write here. Let's make our, let's say, E1 to first input, and the second input, let's say E2, and the output will be O1. Yes, as you can see, our first input is 1, the second one is 1, so the output will be 1. Let's write here, if the E1 is 1 and the E2 is 1, if the O if E1 and E2 will be 1, of course the output will be 1. Yes, let's make one of them 1. As you can see, the output will be 0, and let's switch them. If the another one is 0, the output will be 0. Let's type it again. If the E1 is 1, the second one is 0, the output will be 0. Let's switch the E1 and E2. Yes, let's make E1 0 and E2 1. The output will be 0. Whenever we make two of them 0, the output will be 1. Let's make it 0, 0, and the output will be 1. Let's make it bigger. It's not, I guess it's okay. You see that. Let's make this gate's electronic version. It's too complicated right now, but I will make it. So we learn if the circuit, how we will not how does it work, but we will learn how it looks like in electronic version. First, let's add transistor. Let's make it BC 237, as you can see, and let's add resistor, of course, the main component of every single circuit. Let's add 1 and 4001. It's a diode, kind of diode. And what else we can pick? We can pick redlet to output, to learn what is output. Yes, we can pick this one. And what else we can pick? We can pick relay. Yes, we have it here. What else we can pick? I think that's it. Let's make the electronic version of it. It's scary, but I will make it. Let's put here, first of all, let's put here power, and let's pick here. From here, as you can see, we have terminals mode. Let's pick power and let's turn it. I will move forward that gate, and let's add our grounds. Let's turn it. Yes, 1 2 3 4. Yes, we can add our transistor. Where was it? Yes, we have it. There will be a transistor here, I guess. Yes, there will be here and here. And let's add our redlet. Let's move forward it. And let's add our redlet. Let's turn it. If you see this line in redlet or diodes, the part of the line is negative pole of the diode. And let's continue. Let's connect them like that. And what else we can make? Let's add a diode here. As we know, the line part is negative. And let's add our other diodes. I will make this one like that, and I will have it in here. Let's rotate it. Yes, I guess it will look like that. And let's add a resistor here. I am looking for my from my cell phone. As you understand, it's too difficult, so I cannot make it right now from my mind. And let's add our relays. Let's change the direction. Oh, we don't have to add relay. It's not necessary. We can add switch. Let's type switch, and let's start to. Yes, we can use that guy, and let's add here. Not like that, like that. Yes. Let's connect it. Let's connect them like that, and we will connect these ones. Yes, and we will connect, not like that. Yes, we will connect them. Ooh, yes, what else we can make? We can add a resistor here for the transistor, and we can connect them like that, and let's connect here, and we will connect this diode to these ones. And what else we can make? Let's add our another switch. Yes, we can add here and like that. And what we will gonna do? Yes, let's make like that, and another part. power. Let's move power here and connect them like that, connect them like that, and we will add here a resistor and connect it with power, and the power will go here and will connect here, and we will have to put here a resistor. Yes, and we will connect it here. I guess the circuit is finished. As you can see, the out inputs are 0, two of them 0. The red LED shines, so the output. Let's move. What happened? I pressed wrong. Let's stop our circuit and move forward this guy. As you can see, if they are 0, the output will be 1, so the red LED is shines. And let's close one of them, so the red LED is not shining. I close that one, so why does not it shining? I forgot to edit the components. I make all of the resistor 220 and made the power of the power supply. And let's stop our engine. As you can see, if this part, as you can see, is green, so it means that it's negative pole. So if the switch is like that, it means 0. And whenever like that, as you can see, this part is yellow, this part is orange, I think, not red. This part is positive, this part is negative, so this is 0 and this is 1. As you can see, whenever it is two of them is 0, as you can see, the electricity flows here, comes here and go there, and making and ending circuit from here. But here it comes here like that, flows here, goes through the resistor, and as you can see, there's no other ways to go. It cannot go from the transistor because the transistor has no electricity in base side. So this one too, this one has, but it is no mean because the collector leg of the transistor has no electricity. It doesn't make sense when the base have electricities whenever the collector has no electricity. So we learn the 0 0 part. Let's make one of them 1. As you can see, the electricity comes here like that, and where will he go? The electricity. There is resistance on the LED, but there is no resistance in the transistor, so it goes like that because in base part it has electricity, so the electricity can through the transistor and complete the circuit. So whenever we have electricity in Q2, the number 2 transistor, whenever it has electricity on the base side, the electricity will go here, not in the red LED side, and will go here and end the circuit. And let's make another one. As you can see, the output is 0. Let's learn it. The electricity goes here, goes here, goes here, and coming to the emitter part, and the base part has electricity too. And as you can see, the circuit will end here. Let's put DC ammeter here. Let's rotate it, not like that. Yes, like that. Was it connected? No. Yes, we connected it. And let's connect DC voltmeter to the red LED. Yes. As you know, the voltmeters are connecting to circuit parallel and ampermeters is connecting serial. Let's start. As you can see, there's, let's make the ampermeter millimeter. Let's decrease the value. As you can see, there is no ampere, there is no current in here, so the red LED is not shining because yes, because there has to be resistance current in here in red LED. As you can see, it has it can it can it can be working in 10 milliamperes, so it has to has to be a current in here. If there is no current, the red LED will be not shining. There is volt, but there is no amperes. Whenever I make two of them one, as you can see, there is milliamperes, and the voltage is 2.24 as the red LED wants. As you can see, it's working on 2.2. Yes, we have 2.224. It's not too necessary. As you understand the circuit, if two of them, the inputs are two of them 1, the output will be 1. If one of them 0, or the inputs are not the same value, the output will be 0. If they are same value, at the same value, the output will be 1. Thanks for listening me. This was my third lesson of the logic gates in Nasrettin Hoca Academy. Thanks for listening. See you in next lessons.